This is the View Calculus class. We're doing topic 2, which is limits algebraically. All right, so before we jump into this, let's talk a little bit about some basic steps here. So a limit is fundamentally just a y value, and as we saw in the graphs during topic 1, at spots where a function is continuous, the limit is just the same as the exact y value you'd get by plugging in. So if a function is happy and continuous and doesn't have any weird stuff like jumps or asymptotes or anything like that, then really the limit just is the y value you get when you plug in. So when you're evaluating a limit algebraically, the very first thing you want to do is try and plug in the value you're approaching for x. If you plug it in and you get a number out, that's it. You're done. You plugged in, you got the number 5. Great, the answer is 5. You plugged in, you got the number 57.2. Great, the answer is 57.2. You plugged in, you got the number the square root of 2. Great, that's your answer, square root of 2. But if you plug in and get a 0 on top of a 0, that's what we in mathematics call an indeterminate form. It's not a number. If you get a 0 on top of a 0, you're going to have to use other algebraic skills that you have, and we're going to work through those in these videos, to simplify, and then you're going to repeat step 1. And you're going to do that until you get an answer that when you plug it in, you get a number, and that's it. So a little note here, and it also says this in your packet, when you plug into a limit, you stop writing limit. So I want to give you kind of an analogy of what I mean by that when I say when you plug into a limit, you stop writing limit. So for example, if I asked you what's the square root of, I don't know, let's do, I think in the packet I used 8 over 2, right? You would probably simplify that to a square root of a 4, and then you turn it into a 2. So notice how in these steps I had a square root, but then when I used the square root, I stopped writing it, and boom, I got a 2. Right? See how there's no root here because I did the square root, so I stopped using it. The same thing's true of a limit. So if, for example, I had the limit as x approaches 10 of a 5x, if I plug in 10 for x, I don't write limit because just like when I did the square root, I stopped writing the square root, I'm just going to plug in 5 times 10 and get 50, and that's my answer, right? I didn't write limit in these steps. See how these steps have no limit? So as long as you still have variables and x's, you're writing the limit as x approaches whatever. But when you plug in, you stop writing it. Okay, so that's the idea. We're going to go through a bunch of examples like this. And there's my eraser. All right, so let's start with example 1. All right, so example 1. Oh, I didn't mean to pick 10 in my other practice either, but here you go. The limit as x approaches, they're not always 10, I swear, folks, I really do. The limit as x approaches 10 of this whole thing, right? This whole thing here. So first thing I'm going to do, per the steps, is just try plugging in. So if I plug in, I'd get 10 squared minus a 6 times 10, which is a 60, plus an 8, right? So I'd get 100 minus 60 plus 8, which is a 48. And that's my answer, because 48 is a number. The answer is 48. Notice that the second I plugged in, I didn't write the word limit anymore, right? So limit, not limit, okay? Now, in example 2, we're going to try that, but things are going to go wrong. So, in example 2, I have the limit as x approaches 1 of x squared minus 4x plus 3 over an x minus 1. So the first thing you should do is try plugging in. Now, sometimes you're plugging in your head, to be honest. Sometimes you plug in your head, realize it's not going to work, like you're going to get a 0, and then you just say, cool, I guess I have to do something else. If I plug in, I'd get a 1 minus a 4 plus a 3 on top of a 1 minus 1. Well, that's definitely 0 over 0, which is literally never the answer, okay? That's not the answer. Just to be clear, that is never, ever, ever in all of math going to be your answer, okay? So I go back here and say, okay, how could I simplify this expression? Well, if you think back to when you had pre-calc with me, we did a whole section on simplifying rational expressions. If I factor the top, there's a good chance that I can get something to cancel. So I'm going to go ahead and write limit again, because now that I have x's again, I need to write limit. I think that the top factors into an x minus 1 times an x minus 3. And you can double check that. But my logic was that chances are, since this x minus 1 is a problem, right, 0 in the denominator is always a problem, chances are that the top also has that same problem factor. And you can check by foiling this. You get x squared minus 3x minus 1x, which is your negative 4x, plus 3. Now, these factors would cancel, so this is really just the limit as x approaches 1 of an x minus 3. Well, now I can plug in. Notice I'm not going to write limit when I plug in because I just plugged in, and my answer is a negative 2, okay? So again, your answer is never going to be the 0 over 0, but that's the clue that you need to do something else to try and simplify. Cool. so we are going to do 6 examples like this. So I'm going to go ahead and do examples 1 through 3 in this video, and then we'll do 4 through 6 in the next video. So let's go ahead and do example 3. All right, so in example 3, I have the limit as x approaches -4 of x cubed plus 4x squared minus x minus 4 over an x squared plus a 5x plus a 4. Okay, so the first thing I'm going to do is try plugging in, and we're going to see what happens. So if I plug in, -4 cubed is a -64. Notice I didn't write limit because I'm plugging in. Plus, this will be a 4 times a 16, like a positive 16, which is going to be a positive 64. Minus a -4 would be +4, and -4 would still be a -4. On the bottom, I'm going to get a 16 minus a 20 plus a 4. I'm pretty sure that the 64 and the -64 sum to 0, the 4 and the -4 sum to 0, and on the bottom I get a positive 20 minus a 20. So sure enough, I get 0 over 0, which again is not ever the answer, right? That's a hint that you're going to have to factor and try and cancel things. Certainly in other examples, we'll see some where factoring's not the way to do it, but in these, it's likely I'm going to factor. So my first thought is if x approaching -4 is a problem, so if x equals -4 is the problem, then the factor that I'm probably looking for, just to be clear, is x minus a -4 or x plus 4, right? And that's the problem, right? So I only mention that because some of us don't love factoring and some of us feel like we're not always great at it. And if you can kind of go into it saying, hey, I've got a really solid educated guess that x plus 4 is a factor, it's easier to spot the other factors. So I get x plus 4 times x plus 1, and you can confirm that that would give you a product of 4, right? So you get first is x squared, outer is 1x and a 4x, there's your 5x, and then plus 4. On top, I'm going to factor this by grouping, all right? So the reason I see that it's factoring by grouping is there is no GCF on top, but it does have an even number of terms. So if I take this top term and I factor out an x squared, I'd be left with an x plus 4. And if I factor out a -1, I'd be left with another x plus 4, right? So I think I get that this is x plus 4 times an x squared minus 1. Now, I could keep factoring that if I want. There's nothing wrong with that. You're absolutely fine to factor the x squared minus 1 into an x plus 1, x minus 1. That's great. I will point out that you don't really have to. In this instance, the problem factor is the x plus 4. But if you wanted to keep factoring, notice how I'm writing limit as long as I still have x's. I could make this an x plus 4 times an x plus 1 times an x minus 1 all over an x plus 4 times an x plus 1. And you'll notice that 2 of these factors cancel, and I end up getting that this is just the limit as x approaches -4 of an x minus 1. When I plug in, I stop writing limit, so now I'm not going to write limit anymore. I'm going to do -4 minus 1 and get a -5. Now, right now, I'm giving you problems where it turns out a lot of the factors cancel, but really, this was the only factor that had to cancel for this to work, okay? So in the next video, we'll do examples 4, 5, and 6, which are not all about factoring, and then you'll have some practice problems to try.